Today's goal is to use polynomial functions to model scenarios. Let's take a look at our first example. The function f of x equals negative 1/4 t cubed plus 3/2 t squared plus 1 represents the number of calories burned by spending t minutes working out on a treadmill. You decide to work out on a treadmill and add arm movements that burn an additional 3 calories per minute for the duration of the workout. Write the new function representing the number of calories burned after spending t minutes working out on the treadmill and adding in arm movements. Well, our new function, the number of calories burned, would be the number burned from using the treadmill plus, right, we're burning additional calories, the number burned from your arm movements. Okay, so write a new function. So let's call it c of t. Sorry, this should be a t. Sorry for the typo. Because it's a function of how much time you spend working out. So the number burned by the treadmill, that's just negative 1/4 t cubed plus 3/2 t squared plus 1. Plus, it says you're burning 3 calories per minute. So 3 times t, the number of minutes. If you work out for 1 minute, you burn 3 calories. If you work out for 10 minutes, you burn 30 calories, 3 times the number of minutes that you've burned. We can actually leave it like this. We could box it in. Now, often we'll write it in standard form because that's not a whole lot of extra work. So here you go. Okay, next part. You get hungry and start drinking a sports drink while working out. If you consume an average of 2 calories per minute, write a function for your total caloric rate of change as a function of the number of minutes working out on the treadmill, adding in arm movements, and drinking a sports drink. So this function was the amount of calories we burned by both working out on the treadmill and adding in the arm movements. So our new c of t will be the number of calories burned minus the number we consume. If we want a rate of change, right, if you're consuming calories, that would be taking away calories. Oops, that says backwards, isn't it? Right? If you're consuming calories, you're taking them in. And if you're burning calories, they're going away. So the rate of change would actually be the number consumed minus the number that you've burned. So it says you're drinking 2 calories per minute. So again, 2t. If you're drinking for 10 minutes, that would be 20 total calories minus everything you've burned. So minus negative 1/4 t cubed plus 3/2 t squared plus 3t plus 1. Again, we can leave it like this, box it in, or we can put it in standard form. It'll be positive 1/4 t cubed minus 3/2 t squared. 2t minus 3t would be negative 1t plus 1. So here's our new function for the number burned. Now, let's review and make sure this makes sense. I like to always write my equations out in words before you substitute in an expression so you can check for reasonableness. This function was representing the number burned, right? So it made sense to add because you're burning additional calories. But this is a different function, right? Your rate of change, are the number you're consuming going up or is the number you're consuming going down? Well, if you're consuming, you're putting more calories into your body. If you're burning, you're sort of using them up. Okay, so that made sense why we had those sign changes. Example 2, Erica is remodeling the storage unit in her backyard, which is currently 12 feet by 10 feet by 8 feet. She wants to increase all the sides of the storage unit by the same amount. After sketching her plan, she realizes it's too big, so she decreases 5 cubic feet from her plan. Not sure where she'll take it out, but she'll take it out from somewhere. Write a new equation that represents the volume of her planned storage unit. So volume of cube is always length times width times height minus whatever she's taking away. We don't know where she's going to get that extra 5 cubic feet out of there from, but she's taking away some amount of volume. Well, her length used to be 12 feet by 10 feet by 8 feet, but she's increasing them by the same amount. We don't know how much she's increasing the length, width, and height by, so we can call that x. So her volume will be whatever the length was, we'll call that the number 12, plus some new amount, times the width, maybe that was 10, plus, again, we're adding on to the width by the same amount that we added on to the length with, times the height, so that would be 8. Again, we're adding the same dimension, the same amount to the height, minus this 5 units that she's taking away. Now, we can put this in standard form if we want. We would use the box method on 12 plus x times 10 plus x, use a gigantic box method then to multiply by 8 plus x, and that sounds like a lot of work, and then we would subtract the negative 5. Because the question did not require us to give our answer in standard form, and because that would take a lot more work, we'll actually stop there. Alrighty. Example 3, the number of people waiting in an auditorium for a rock concert to begin is modeled by the function n. So n would be a number of people. N of t is 460t cubed minus 169t to the 4th. Oh, weird, this isn't in standard form. Plus 135 for 0. T is between 0 and 2 hours. Doors close and the concert begins at t equals 2. How many people are waiting in the concert auditorium 2 hours before the start? Well, if it starts at t equals 2 hours, 2 hours earlier would be t equals 0. So how many? We're just looking for a number. So we're going to substitute. So this is just n of 0. 0 represents 2 hours before the beginning, is 460 times 0 cubed minus 169 times 0 to the 4th plus 135. So n of 0 is 135. So there are 135 people in the auditorium 2 hours before the start of the rock concert. And we made sense of that because 2 hours before would be t equals 0 if t equals 2 represents the start of the concert. All right, last question. Each person waiting heats up the room by 0.014 degrees Fahrenheit. Write a function h in terms of t that gives the temperature. Okay, h is the temperature in the auditorium for t is between 0 and 2 hours. Assume that the temperature inside the auditorium is 72 degrees Fahrenheit when no one is inside. So this is like our baseline. All right, let's make sense of what's happening here. People waiting heat up the room. So that means our temperature is going to increase. Well, it would increase from what? Well, it would increase from a baseline. You have some temperature it is, plus it's getting hotter in there. And how hot is it getting? By 0.014 degrees Fahrenheit per person. So it would be 0.014 degrees Fahrenheit times the number of people waiting. How many people are waiting? Oh, that's our function n of t. N is a number of people. So our new function, the temperature, h of t, is our baseline, 72 degrees, plus 0.014 times, number of people is just that old function. It was 460 t cubed minus 169 t to the 4th plus 135. Again, put it in standard form if you wish, or this is actually enough. It does help to double check your equation in words. Temperature would be baseline plus additional. That makes sense because people are heating it up. Times the number of people. Yep, this makes sense.